All right. So next thing in the list is 76. Minimum. Oh, it's a hard problem. Minimum window substring. Is this recording? Yeah. All right. Given two strings S and T of lengths M and N respectively, return the minimum window substring. Substring is contiguous. Yeah. Minimum window substring of S such that every character in T, including duplicates. Including duplicates, is included in the window. Okay. So if there is no such substring, return the empty string, blah. Wait, so you've got two strings, M and N respectively. respectively. Return the minimum window substring. So get the substring such that every letter in T exists in that substring, basically, including duplicates. So I'm assuming that means like if T has a duplicate. Yeah, so like here, even though there's an A, you need two A's in the substring in order to accommodate the two A's in T. So that's a problem. Okay. And it needs to be sort of linear-ish time. Okay. I might need hints, Hard problems are scary. What's the acceptance rate like? Is it like quite high? Oh, okay, it's 50. That's not too low either. The test case will be generated such that the answer is unique. Interesting. Okay. So taking this example, maybe I'll write the type. So 76 minimum window substring. Okay. 76 minimum window substring. Okay, so basically, I guess like the question kind of becomes, let's just take a massive window first of all, right? Like, I think if it is window stuff, I think my idea would just be have a left and a right pointer. So this is like my S string. This rectangle represents my S string. And then like you have a T string. And like it'd be something like start with L equals 0, anchor it there, and like move R along, blah, 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 up to let's say here, when at this point we have a window that, what's the word? That accommodates to the condition. Like all the letters in T exist in this window. So this is like, with L equals 0, this is the smallest window that works, so to speak. Like this is the smallest window with the condition that L equals to 0. This, by iterating R down and continuously checking, this is the smallest window that exists. Then, as we do that, L, the left pointer, should then increment down until we find the point, the cutoff point, the point where, if we were to go one more across, the condition would no longer hold true. And I think it's just that idea of like, yeah, if we go again, we find this, and then we go again, and we find the cutoff point, and we go again and again until we get to the end of the array. And then, yeah, we continuously kind of look for those cutoff points for L. But can I prove that works? Because that's like an intuitive idea. I don't actually have a proof there. I hope that made sense, actually. I'm looking back at the screen, I'm realizing it's just a lot of squiggles. I'll say to get a bit more formally. Maybe I'll use an example as well. Maybe the example will make it a bit more concrete. But yeah, that's my initial like, zero shot thinking, like based on whatever experience I've had with these window strings and whatever, substring windows and whatnot. That's where my brain goes straight away. So Adobe. Oh, Adobe. Adobe code. Oh, it's like got a bunch of words. Okay, code, and then bank, but with a C. So that's that, and then T was just ABC, right? So if I take the S string, Adobe, CODEBANC. So I have the left pointer starts at here, and the right pointer also starts here. So they both start at 0. And basically I ask, okay, does the current substring have all three letters A, B, C? Like, does it contain A, B, and C? The answer is no. So I move R down. Does this guy have A, B, C? No. Do you? No. Do you? Well, you have the B now, which is great, but no. Do you? No. Do you? No. Oh, yes, sorry. At this point, yes, the answer is this string has the A, the B, and the C that, belong to T. So, at this point, my min length would be set to 1, 2, 3, 4, 5, 6. Or maybe actually, better is to keep... Maybe actually, yeah, min length would be 6, and like the L value required would be 0, the R value would be 0, 1, 2, 3, 4, 5, right? I should have known that, actually. It's 6 letters. That's cool. So now we know that like somewhere along the L and R, somewhere between L and R exists our ABC. That's what we found out. Now, in this case, actually, if we try to move L down, we'll see that we actually lose the A. So it's like, okay, this is a problem. Trying to move the L down causes like the string to lose the ABC nature, right? So I think at this point we can ask, okay, if we want the window to end at R equals 5, then L has to equal 0. That's basically what we've discovered so far. If we want R to end up here, then L has to be here, because otherwise that A won't exist. So then, we ask kind of a similar, we know that there's no point in restarting R here, right? Because like, if this window had ABC, then there's no way that this window is going to have ABC. You know what I mean? Like, there's no point in bringing R back to L. We can keep R here, and then we can keep incrementing. Does this have ABC? No. Does this have ABC? No. You, no. You, no. You, no. Yes, sorry. Now we do. So we found another string that has ABC, and the question is, okay, well, what is the smallest, if we want to have R here, what is the smallest window we can have? Well, we move L down once. Do we still have ABC? Yes. Do we still have ABC? Yes. Do we still have ABC? No. Right? So if we want, ow, sorry, I elbowed my table. If we want R to equal 0, 1, 2, 3. Oh, actually, no, we would have ABC, wouldn't we? Because the B is there now. Sorry, I was wrong. So, sorry. So the L was here, wasn't it? Whoa. The L was here. Do we still have ABC? Yes. Do we still have ABC? Yes. Do we still have ABC? Yes, because there's another B over there. Yes. Do we still have ABC? Yes. Do we still have ABC? Now it's no, because C is lost and we have no other C's to bring it back. Fine. So if we want R to equal, what is it? 0, 1, 2, 3, this is 5, 6, 7, 8, 9, 10. If we want R to equal 10, then the biggest L can be is, I think 6. Yeah, 6. Right? L has to be at index 6. Okay, fine. And then from there, I'll get rid of the arrow. It's not necessary. So again, if this is like the tightest window we can have for R equals 10, if we were to make the window any smaller, we definitely won't have a valid string. So we can just, again, keep incrementing. Do we have ABC yet? No. Do we have ABC? Yes. Do we still have ABC? Yes. 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 No. So L should be there. So if we want R to equal, I've already forgotten, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we want R to equal 12, then L should equal 12, 11, 10, 9. And the question is, okay, out of these three sort of relatively small windows, which one is the absolute smallest? And I assume it's the last one, right? This is 4 characters. This is 5 characters. This is 6 characters. So you pick this one. So you say, okay, take this S string from L equals 9 up to 12, all inclusive. So this guy. So it does give the right answer. And I do kind of back it. I wouldn't mind being able to think of a proper proof. Like, obviously, this is proof by example. It doesn't really count. But I think it makes sense. Just intuitive, like intuition is telling me that this should be right. Because in essence, when you do that kind of process of like bringing the R to the right place and then bringing the L, what you're basically finding is the smallest window for a particular R value, right? And so for all the R, so yeah, so like for the smallest window for a particular R value, if you find, if you have a particular R value over here and then the L value somewhere over here, and you see that, hey, look, this is actually, this is actually as good as it gets. If you were to move the L anymore, then you know that the window doesn't work. Well, that's what we're checking directly. And if we move the window further back, we're making the window bigger. So we're finding the smallest window possible for a particular R at any one point. So if we just find all those, for each particular R, if we find all the smallest windows, then we just take the smallest window overall, and that should be fine. That would be my sort of hand wavy proof. Is there anything else I can say? Like, it's another way of, can I say like it's the same thing as saying for a particular L, what is the smallest? Because we do ignore a lot of R values as well, right? Like we jumped over a lot of R values if they don't give a valid index. And that basically means that they don't count. Those R values aren't important if they don't give a good substring, a good window. So I think this is right. So I think to lay out the general process, initialize with L equals 0, R also equals 0. So we're starting with a window of size 1, right? L to R being a 1 character window. And then we're going to have to think of like efficient ways of looking this up. But while like the condition is not satisfied, basically, increase R until the condition is satisfied. That is, we have all the characters in T. While the condition is still satisfied, increase L until the condition is not satisfied. And then like basically just L minus 1 up to R is inclusive. L minus 1 up to R inclusive is the smallest window for that R, okay? And then from there, we repeat the process. We go back to here and do this again. And then we basically, min across all the smallest windows for each R, basically. Yeah, okay. And now the question is, how do I efficiently keep track of whether the condition is satisfied or not? This is the extra bit of pre-processing I need. So it'll be something like some kind of frequency checker. So like, let's say T is A, B, C, A, right? Like, let's say that's the T value. I can be like, something about can I how does she use a hash table? Does that work? Like, you know, at the very start for the blue example up here, A was with a frequency of 1. The issue is I feel like right now my checking of the condition is going to take O of n time or whatever, however long t is. Sorry, yeah, O of n, like, if that's O of n, and that's O of n, like, if the checking is O of n, then this entire thing will be O of, I guess, mn. I think it's like, I think right now my thing will be of O of, yes, like, O of mn squared or something. Like, you know, like, it'll be something weird. So I think it's way too long right now. I need to have a more O of 1 time of checking if the condition is satisfied. Condition is not satisfied. Like, I'm thinking like how am I doing it as a human? Like, I'm basically saying, okay, I know there's an A, so I write that down. I see there's a B, I write that down. I see there's a C, I write that down. As soon as I leave the first A, I like pop, like I cut it, right? Maybe I can have like a, okay, this is another idea. It's a bit weird, but I think it can work. In my T, in the hash table that I'm sort of thinking about, I write, the keys will be all the letters I need. Wait, what was it was ABC, wasn't it? Sorry, ABC, that's the T letters. Those are the letters in string T. And the value that gets mapped is not just, you know, how many I need or how many I have, it's both. It's how many I have in the window at the moment, and then how many I need, which will be 1. So like 0, 1, 0, 1. Now on top of this, I think I want to have a set as well that contains all the elements that are not satisfied yet. All of the letters that don't have enough yet. So like originally it'll be A, B, and C. Like all 3 letters aren't existing in the window yet. Then when I see that first A, this will increase by 1, which means I have more A's than I need, which means I don't need this in the set at the moment. You know? And then I see a B eventually, so I increment the count by 1, so I don't need a B anymore. Then I see a C, so I increment that count, and I don't need that anymore. So once S goes to 0, well, when the length of S goes to 0, I know that the condition is satisfied. I know that I have enough enough of the letters to to satisfy the condition. Then as I start moving L down, I'll lose an A, right? So that count should go down, which means this guy should go up, which means now the length is greater than 0, so the condition has failed, which is expected. So I think the combination of a set plus a hash table will let me look up, you know, what if I've satisfied the condition of having all the letters in T in my window. So let's see if that works. We'll start by we'll say L equals 0, R is equal to 0. We'll have a hash table. For C and T, so C is going to be the key of the hash table. HT at C is equal to 1 plus HT.getC or default to 0. So this should accurately, oh wait, no, this is wrong. Is that right? And then my set will be, I called it S in my working, but we'll say still need. So we still need, we still need an A, we still need a B, we still need a set C. And then we'll say still need dot add this character C. So I think this will accurately initialize everything I want. So the hash table with the T letters being the key, and then we're making a list where the first element is how many we see in the window, which is 0 at the moment, and the second one is how many of this letter we need. So of course, you know, for ABC we always need one of each. We need one A, one B, one C. But for example, if T looked like ABCA, then the eventual hash table should look like A0, 2, because I need two A's, not one. B would be 0, 1, and C would be 0, 1. Still need that, and then yeah, still need, I'm just adding all the letters I see because that's what I need. For this C and T, we got, okay, so I've initialized that as required, and then basically I think I can just follow this. So I think I'm gonna need like a while true, or while r is less than, I'll say slen is equal to the length of s. While r is less than slen, so while r is still a valid index, maybe I should, sorry, what I should do is I should say if SR is in, this is basically me handling the very first character. If SR is in still, is in HT, right, then HT first char is equal to S at R, and then HT at that first char is equal to 1 at index 0 is equal to 1. So I'm just changing this value to 1 for the very first character. God, I'm actually being a bit silly right now. What am I trying to do? Do I need to do this, Nick? Can I just... I think I can do it within the while loop. I don't know why I did it like that. Current char is equal to S at R. If current char is in the hash table, then HT at the current char, index 0 should increase by 1. If HT, maybe I can be like, if current char is not in HT, then continue, just so I can reduce the nesting a little bit. Otherwise, we know that it definitely is in HT. We can increment this count by 1. If HT current char 0 is the same or greater than HT current char at 1, then we know that we have sufficient amount of that letter in the window. And if it's also, if the current char is in the set, still need, then what am I trying to do? Then current still need, is it remove dot remove? I think this is the method. So this is me like getting rid of that. And then if the length of still need after trying to remove it is equal to 0, then we know that the condition has been satisfied. I'm just like making variables for keeping track of the best answer so far. Smallest window size is equal to float infinity. You could also say is the size of s plus 1, but we'll just do that for that sake. While length of still need is greater than 0, we increment... Ooh, wait. R plus equals 1. H current char... Otherwise you can increment this, do this, remove it, and then increase this by 1. Hang on, wait. What am I trying? Because I don't think I want to increase R if we end up... If the length of still need is greater than 0, then we need next R. Otherwise, we know that we'll break out of this while loop anyway. Anyway, once we've broken out, we know that at this particular L and at this particular R, we have a valid window. And then while length of still need is equal to 0, we're looking at current char is equal to S at L if current char is not in the hash table, then no worries, continue. Otherwise, ht at current char at index 0 should decrement by 1. Whoa. If the hash table is now strictly less than the current char, then you need to add it. And this will cause this while loop to break. So what this is saying is, if you remove this elf character, then the window will no longer be valid. So otherwise, if this doesn't cause the window to no longer be valid, you can increment this by 1. So once we finally break out of this, when we break out of the second while loop, then we know that we have found the L and R, the smallest L and R, such that we found the smallest window given R is fixed at this particular position. So then if R minus L plus 1, if that's smaller than the smallest window size, for this kind of exercise, I believe R minus L plus 1 tells you the current window size. If it's smaller, then the required L is equal to L, the required R is equal to R, and the smallest window size is equal to R minus L plus 1. Have we done it? Oh no. I think logically, intuitively speaking, I think it's generally correct. I just don't know if I've written it correctly. For C and T, so I back this hash table, and I back the use of this set. L is equal to 0, R is equal to 0. The length, I've just written like that, just to, I don't know why. This is just to mark it as, maybe I'll just say none. Might as well, right? Smallest window size is infinitely big, while R is less than the S length, while we still have letters that we need to cover. We get the current char in the right index. If it's not in T, then this isn't going to affect anything, so we just increase the window size by 1 and keep going. Otherwise, we know that we have one extra one of these letters that we might want. If the amount we have is at least the amount we need, and this current char is in the set, indicating that before we added this character, we didn't have enough, I mean, I think we could also just say if they're equal now, then that indicates that current char should be, but we'll just do it like this. It's more explicit. We can remove the current char. If the length of still need is greater than 0, meaning that we still have letters we have to remove, then we know we should increase r by 1. Else, if this is not the case and it's equal to 0, then we know this will break. So that's the way I'm doing it. Anyway, now we found where we've given the particular L, we found a place in R where R has to be in order to make a valid window. So while this is still 0, while the length of still need is still 0, get the current char that we're planning on removing. If it's not in HT, then that's not going to be this L is not going to affect anything. We can make the window smaller. HT at current char 0. Otherwise, the HT, the amount of this character we have, should decrease by 1. If HT of 0 is now less than HT char 1, so if the amount we have after losing this elf character is now less than the amount we need, then you should add this back to the set. In which case, this will cause this while loop condition to break, so which is good. Else, there's no drama, like we still have a valid, like removing this letter will still allow for a valid window, so we can just increase the window size, decrease the window size. And then that should, and once we break out, because we added something to the set, if r minus l plus 1, I am worried about index things. Like what if we increase L so much that like this is out of bounds, you know? So I'll have to check that. But let's just pretend that nothing bad happens. If r minus L plus 1 is less than the smallest index, then yeah. And then basically, we're returning the string, right? Yeah. So essentially, I believe we'd want to return, what am I doing? Yeah, return, I think, the S from L up to R? Is it R plus 1? So I think I'm using R as like where it has to be, like where it has to be. So I think I need to do R plus 1. Now I think there's going to be index errors. I think there's going to be places where that's a problem. Like maybe if the S string doesn't have any of the letters, then there's going to be a problem. So I think I have to say while R is less than, while R is less than something. What was I doing? While R is less than slen. Oh, yeah. And this is the case. That way we know that there will be a valid index here. Blah, blah, blah. Other thing I can do is if L is none and R is none, that indicates that we never updated these values, then we return the empty string, because that indicates that we never managed to satisfy the condition. Current char as SR. If current char is not in the hash table, move along. Otherwise, do all this stuff. I think I back it. Yeah, it makes sense generally. If the length increases by 1, if we still have letters we need to get, then increase the window size. While the length, same kind of thing here. While L is less than than slen, and while it's still a valid index, get the current char. Now, yeah, and then what I should do is something like if L is greater than or equal to slen, if L is greater than or equal to slen, or R is, wait, yeah, R is, because this is basically, if either this is true, this is basically saying like, look, I couldn't, then I guess you can just like continue basically. Like I want to skip this. I don't want to try this if I I don't want to try this check if like R is invalid, because I'm worried about something like if L is somehow bigger than R, then this goes negative, and then this is smaller than the small. I don't know. Like I'm just worried about something dumb happening. Um, but yeah. Let's see what happens. I'm pretty sure this is. I might have been a bit paranoid, but oh no, I'm stuck in a while loop. Oh no, oh no, no! I try to be careful. Ah, damn. I'm surprised. I would have thought that each branch, like either this makes L go up, which will sort of handle this condition. This will cause this condition to break. Else this will cause this eventually to break. If length of R is greater than 0, then increase this. If this is the case, increase this, which will cause this to break eventually, or this will break eventually. Or we'll remove this, which will cause this to break eventually, because this will go to 0. Is it the outer loop? Print outer loop inner loop 1. I feel annoyed. Inner loop 2. See if we can figure out which one it's getting stuck in. And then it'll let us sort of narrow down the variables. Outer loop, outer loop, outer loop 1, 2, outer loop 1, 2. Interesting. R equals R. I'll just print S length and stuff as well. S length. Maybe I'll do it here actually, because it might not be seen. S len is equal to S len. R is equal to R. S len is equal to S len. Do I want the still need or do I want the length of still need? We'll just do length. Still need len is equal to the length of still need. Checking all of these lovely conditionals. L is equal to L. S len is equal to S len. Still need len is equal to the length of still need. How fun. This is what we like to see, isn't it? Alright. Whoa, that can't be right. Why is it 13? This is the one that's ABC. Did I do the wrong string? Outer loop printed S length is... Oh wait, S length. Sorry, I was thinking that was the still need. Sorry, I'm stupid. 13 is fine. Yes, that is correct. I guess we simulate. I don't know. I am thinking of something. Hang on. In this loop, right? Do I ever actually remove? I add. Sorry. Should I be adding? Still need add the current char. Like, shouldn't I be increasing L or no? trying to think if my logic is wrong. If HT current, like if we don't have enough, then add it. I think we still want to move along because, yeah, I think that's what's happening. I think I forgot to increase. Like I thought I wasn't meant to increase the decrease the window size, but I think I am because I want to be able to explore new options. Like once I hit this tells me, okay, look, um, this is the biggest L I can have. But if I keep that L in the same place, then the L and the R isn't going to move because it's not going to want to get rid of anything. So I think this is the issue. I just had a bit of a logic issue. No? Okay, fine. Guess I was wrong. S length is now 1. Excuse me? Now I'm confused. Why is S length 1? Oh, unless actually it might be a different output. Right. Good. So this should have... What? Okay, so let me think. R went to 0, and we found a valid thingy. We found a valid window, right? Because this would satisfy this. And then what happened after that? We tried to see where L should go, and wouldn't L have increased like this? Maybe I need to say while L is also... Because L would have increased past, right? I think I need to say while L is less than S length and R is less than S length, just because, you know, that might... Can I break here actually instead of continuing? I don't know why I said continue. I meant to say break because at this point there's no way you can have a valid window. Oops. What? Oh, right, lol. Oh, it doesn't work the way I thought. Yeah, that was silly of me. If C is in... Okay, I'll do this like a weird way. Then HTC is equal to 0, HT at C index 1 plus 1, else HT at C is equal to 0, 1. This is getting the previous value and adding 1 to it. This is just setting it like that. I guess having a repeat was causing problems. Damn it! Ooh. Because now the L is being... So this needs to be L minus 1. Isn't it? The required L... Oh, see, though, this is the issue. That's why I didn't want to increment. That's why I didn't want to increase the window size. So I thought I wanted to keep track of where the L should be for that window. Maybe I'll say like... Oh, man. Can I just say L minus 1? Is that fine? So L minus 1 because that's the actual... That's where the... Like, are all the answers like 1 off? Ooh. Okay, that might be a problem. Oh wait, I did the wrong thing anyway. This should be required L. Now I'm really confused because I don't know what I've done wrong. As in, I have ideas of what I've done wrong, but I'm not actually sure. Like after I've found the point where L can be, I still increase L by 1 in order to keep the process moving. However, once I find that that rightmost L that I can have, that smallest window, and L increases by 1 to make one window smaller, the window a little bit smaller, this will add, breaking me out. I check this because if see, this is the issue now because if L minus 1 is an invalid index, I think. Because L minus 1 is what points to the character that I need to start the window at, you know? Because I'm increasing L always. Like, even if I've found... If L minus 1 is greater than or equal to S length, or... Oh, man. And the smallest window size is that. No. No. All right, I'll just have to do some more printing. Let me see, what can I do? I think I can print here saying like, look, window at R equals R is valid, I think. Print will say L starting at L, and then window at this is valid. Smallest window for R equals R starts at L equals L minus 1. All right, L starts at 5. Then the window at 0, 1, 2, 3, 4, 5 is valid. Smallest window for R equals 5 starts at L starts at 1. That helps us keep ticking. Window at R equals 10 is valid. Wait. Uh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are you sure? 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, no, yeah, 10. That's good. Yeah, that's the A. Smallest window is L equals 9. That can't be right. L equals 9? Oh, dear. So, yeah, it thinks L being at the B and R being at 10 is good, which is where I gave BA as the window. Smallest window... So that means that it thought... D, which started at 10, it's like with D, which L, which started at 1, found the correct place for R, which was 10, but then incremented L. It incremented L until there. It should have incremented till there because after you lose that C, you don't have another C. Why did it, what? If, let me just print HT at the very start, just so I can see what it looks like, because it should have a C in it, just for my own understanding. There's an A, yeah, there's an A, a B, and a C. Yeah, good. Okay. So we have string is, can I make this a bit small? Or maybe I can make this. Okay. So L starts at 0. Eventually R gets to 10 with L starting at 1. And then window R equals 10 is valid, right? We know that. And then reading this code, it's like current char is D. It's not in HT, so that's not going to affect anything. Increase. Oh, this one is in HT. So let me decrease the amount we have by 1, but we have another B. We would have seen another B at this point. So that should be fine. And then this isn't in, this isn't in. But once I saw this and I decreased this by 1, this should have gone to 0. For the count for how much we have for C should be 0, and the amount of how much we should have for C, it should be 1. So then this should run, and then still need dot add should do the thing, and then we should break out. Right? Like I'm confused. Let me print the HT at this point. So print L is equal to L. Let's put a couple of tabs or something. Let's try to do some kind of nesting. Unterminated. Whoopsies. My bad. I've been doing this for longer than I thought. I thought I'd get it by now, to be honest. I thought I had it. All right, so let me look at this. So R equals 10. L equals 1, L equals 2, L equals 3, right? So for L equals 1, L equals 2, L equals 3. So first L equals 1, L equals 2, it would have been, you know. Ooh, it thinks there's 2 C's. Why does it think there's 2 C's? Where did 2 C's come from? Okay, so that's the issue. It thinks I have 2 C's. It thinks I have 1 C by the time I get to 0, 1, 2, 3, 4, 5. Ah, but I need to... Wait, what? Why? Yeah, why did it increase again? It thinks I have 1 C. Do I seriously have to, like, print all of the... Why does it think this? I'm so confused. R equals R. And then I print the hash table after the update. This is such a long day. Why does it think there's 2 C's? Where did 2 C's come from? I only ever increase when R passes over the C. So, and I haven't hit that C yet or anything, so I don't understand where. Oh, this is gonna get really weird looking. Hang on, let me. Okay, R equals 0. Then you have A11, yep, and then R equals 1, A equals 2, R equals 3. The B increases by 1, good. R equals 4, R equals 5. Then we have valid, right? Because we would have popped off A, B, and C off the set, from the set. Then L equals 0. We would try decreasing, we would have a problem. So smallest window, R equals 5, starts at L equals 0. Good. L starts at 1 now. R. Why is there 2? Where? How? Where? From here to here, what happened? Don't make me print every time we do an increase. I only wrote a plus equals 1 thing once. Like, where else would it be like, these always set it to 0. If I do regex, it's like some stuff plus equals. Oh. Is brackets important? Is brackets like a thing in regex? I forget. There you go. Like, assignment-wise... Wait, why did that match? No, I'm just exposing my inability to use regex. Oh, because it matched up to... No, I didn't get it. Anyway, it's fine. But I only have an increase here, right? Okay, let me print... I only have increment it here, so let me just also... Increasing supply for Kerchar. And then... This video is going to be too long, bro. Increasing supply for A, increasing supply for B. Okay, so it increased supply for C because R is already at... Ah, right. I probably should have realized that, yeah. Because R was at 5, and then it stayed at 5, and then it went to 5 again. So I think it is relatively safe because L, like, because the new L, after we, you know, established the good window, the new L is 1 past. So the same R isn't going to be, the same R isn't going to be good anyway. So I might as well increase R again. After I've kind of done all this processing. Damn. That took way too long. I should have clocked that, actually. I never increase R after I've, like... It's like the same issue with the L. Like, I had the same issue twice, basically. For both sides of the window, and I didn't clock it. Now I had to question... I mean, I think... Logically speaking, I think the... I can basically see the proof. Like, I think it makes sense. Like, you know, you're always keeping track of what's in your window pretty efficiently with the hash table and the set. You're pretty accurately figuring out how small you can make the window while keeping R fixed. And you're also seeing where R has to be for a particular L value. So you're kind of with the intersection of those two kind of checks, you are always finding the smallest window at any particular point, and then you just take the smallest overall. I think it does make sense. I might have some other mistakes though. I might try some small test cases. I mean, it's good that they had the AAA case, like this one. How small? So like if I have like M and N, like one character where there's no valid thing. Okay, so that's good. It knows to return that. Good. And then what if I have like A, B, C, D, E, F, G. It's like A, B, C, D, E, F, G, X. I guess, yeah, a quick check we can do is like if the length of T is greater than the length of S, if the length of T, then we can return the empty string straight away, right? Because it's like, since we're including duplicates, the length of S has to be longer than length of T, unless there is a, yeah, there's no condition saying like, oh, T will definitely be shorter than or equal to S. I didn't actually add any test cases. So yeah, let's say like T is like this and S is short, then it should give me the empty string. that doesn't really, I didn't really, that's not really sufficient. Whatever. I don't know what else I can test. What else can I test? Boom, boom. Maybe some like border stuff. Like what if the window I want is like on the very end, like making sure I'll just do like all capitals on this side. And then I need on the very end, I want ADS at the end or SAD. Maybe with the capital S. So it's like the last 4 characters I need. All right, I back it. I have full faith. Oh, I punched my lamp. Sorry. Right on the mode. The idea was right. I'm just dumb. Okay, very good. I think that's enough for today. What was the absolute, like... Fair. See, I'm not good at this. I need to remember to use this thing, because I've seen this enough to know to do that, and I've forgotten. Okay, so they didn't need to do, like, an array thing for the values of the hash table, which is quite impressive. Yeah, I'm actually curious. How do people contain the maintain the condition? Oh, they do all this weird stuff as well. So yeah, you're basically you're doing a count. So this is telling you how much you need. This is like the amount you need. Length, count, infinity, length, SI is equal to -1. It's just like, I don't know what that is. While r is less than n, if the map, what's map? Is map the hash table? Yes, it is. So if the map of SR, so if it's in the, if the current character in the right is in the map, then count should increase by 1. Otherwise, what? And then map. Okay, so you're instead of having 2 separate numbers, you're basically using 1 number. Fair enough. As you So it's like you're using like negative. If number's negative, that means you have more than enough, and if the number is positive, it means you don't have enough. While count is equal to m, so saying while count is equal to m means so because the count is indicating how many letters you have that are actively contributing to the T string. Like how many letters in your window do you have that are actively contributing? So if you can get count to equal m, that indicates that you've hit the condition well. Okay, that's fair play. Then you try to make the window shorter. If it's greater than 0, then the count. Yeah, there you go. So if you get to a point where the count, if you get to a point where the map at the leftmost character is now positive, then you know that, okay, I need more than I have, basically. So the count should decrease by 1, breaking you out of here. It's a similar idea, except it's far cleverer in terms of how it keeps track of everything. Using a hash table in a set now feels silly. It feels a bit overkill. Yeah, I think I had like a inkling that this would work, but I didn't think to use the positive negative. Like I felt like I didn't really need the set, but I couldn't really think of what else to do. But yeah, this makes sense. Using a count that just keeps track of how many matched characters do you have that are sort of, yeah, that's good. I don't know what this is for though. Like, I don't know if it's a speed thing or what, but anyway. And then there'll be some people who are like, would brute forcing work or something? I mean, it looks pretty similar. Check. I'm assuming it's the check that's a bit like long. Yeah, it's like going through the hash table probably. Is T counter your? Yeah, it's your hash table. Fair enough. Yeah, that's what I figured. I figured the hash table checking, like the condition checking, would be the tricky part. All right, well, we got there. If it was a little bit dodgy. All right.